All right, there we go. So I had screwed up the even odd test. Okay, so if x mod 2 is equal to 1, that is to say if we have an odd numbered run through our outer testing loop, we're going to bias the probability towards removing from the queue. Otherwise, we're going to bias towards adding to the queue. Okay, good. So this time, we added to a non-full queue 600,000 times, added to a full queue almost 400,000 times, removed from a non-empty queue 600,000 times, and removed from an empty queue close to 400,000 times. So this time, even with a 1,000 element queue, by adding this bouncing back and forth behavior, we managed to do a good job random testing. And so if you think about it, this idea of adding a new outer testing loop to a random tester is often a pretty good one. And so if you think about it, that's exactly probably what we would end up doing for the file system example. So if we special case mount and unmount, probably what that's going to mean is hard coding a call to mount at the start of the random file system test, then executing a bunch of API calls, that is to say opens, closes, make directories and stuff, and at the end we're going to hard code an unmount call. What that fails to do is interesting stress testing of the mount and unmount logic. And so remember, if we called mount and unmount with equal probability as the rest of the calls, that was too many times. But if we hard code a call to those at the beginning and end of our entire random testing run, that's probably too few. So what we can do is mount the file system, do a bunch of stuff, unmount it, and then enclose that in an outer testing loop that makes sure that we sort of stress all the parts of the system that we intend to stress. And so you can imagine that the state machine for the file system case is considerably more complicated than the state machine for the queue. But on the other hand, we could still do this diagram or something like it, and what we'd find is that we need to adjust our probabilities. So since this is sort of a deep topic and it's a difficult one, let's look at one more example.